In the rainforest, a hunter lifts a long, narrow tube, takes aim at an animal high in a tree, and blows. A tiny dart shoots out. At first, this seems almost impossible. Human breath is weak. It cannot compare with a bow, a spear, or a gun. So how can a simple blowpipe send a dart far enough to hunt? The answer is that the blowpipe turns ordinary breath into directed airflow. When we breathe out normally, air spreads in every direction. Most of its energy is wasted. But inside a blowpipe, the air is trapped and guided. It has only one useful path, forward through the tube. The dart fits closely inside the pipe. That close fit matters. If air could easily leak around the dart, the pressure behind it would disappear. But when the dart seals the tube reasonably well, the air pressure from the hunter's breath builds behind it and pushes it forward. This is the first key idea, pressure difference. Behind the dart, pressure is higher. In front of the dart, pressure is lower. The dart moves from the high-pressure side toward the low-pressure side. The second key idea is acceleration over distance. A very short tube would not give the air much time to act. The dart would leave almost immediately, still moving slowly. A long tube lets the pressure push the dart for a longer distance. That longer push gives the dart more speed before it exits. This is similar to why a longer barrel can help a projectile gain speed, as long as the force continues acting on it. The dart itself must also be light. A heavy object needs much more force to accelerate. A blowpipe dart is usually slender and lightweight. Human breath can accelerate it because it does not have much mass. But lightness alone is not enough. The dart must also fly straight. The tube gives it direction. While the dart is inside, it cannot wobble freely. It is guided along a fixed path. By the time it leaves, it is already aligned with the target. Some traditional blowpipes also use darts treated with poison. This changes the role of the weapon. The dart does not need to strike with the destructive force of an arrow. It only needs to pierce the skin and deliver the toxin. That is why a light dart, driven by breath, can still be effective. There is also a lesson here about simple technology. The blowpipe is not advanced in the modern industrial sense. It has no metal engine, no battery, no explosive powder, but it is carefully matched to its environment. Dense forests limit long-range visibility. Animals may sit high in trees. A silent weapon is useful. Lightweight materials are available. Plant and animal toxins may be known through generations of experience. So the blowpipe combines physics, biology, and human skill. Its science is clear. A sealed tube concentrates air pressure. The long barrel allows acceleration. The dart's low mass makes it responsive, and the tube gives it direction. A breath by itself is weak. But a breath focused through a long tube becomes a controlled pulse of moving air. The result is a weapon that looks simple but works because it uses pressure and motion with precision.